One neat type of problem we can tackle what day is today? March 27th, right? March 27th. I hope I spelled that right.
This goes in Paul too?
This is Paul.
I mean, 8.2.
Huh?
This is part 8.2.
Yeah, this is part of 8.2. Paul borrowed $1,000 on March 27th for 150 days at 17% APR, annual percentage rate. How much will he owe on the day of maturity? Is it 2 T's or 1 T? Okay, I always want to put 2. That's my bad habit. What's the day of maturity? The day that the loan is due. It comes up. It's ready to go. So you need to pay back some money. All right. So the first thing you have to do is you have to convert March 27th into the day of the year. So you go to March 27th, which is today, and it is the 86th day of the year. So this becomes, for us, 86. Now, I owe the money 150 days from the 86th day. So what do you think you do with those two numbers? Add them. So you do 150 plus 86. That turns out to be 236. And day 236 is August 24th. So he owes the money on August 24th. The principal plus, if you were paying off your loan, you're going to pay back how much you owe plus interest, plus the interest. These are what are considered common sense problems. The problem with common sense is nobody has it. Nobody has it. Go for it.
Why I didn't catch that when you put that 86.
If you look on the chart for March 27th,
Okay.
it's the 86th day of the year. And you add 150 because you owe it 150 days later. So on day 236 on the chart, it's August 24th. All right, so how do I find out how much interest I owe? Well, there's two formulas. Which one do you want to use? I equals PRT. So I equals PRT. Do I know how much interest I owe on this loan? Or Paul owns on this loan? No, so leave that alone. But write it down. So I equals, do I know the principal?
Oh, yeah,
1,000. Do I know the interest rate?
17%.
So I write it as 0.17 times 150 over 365. Now again, banks will use 360. I'm not sure. I think the textbook uses 360. But I prefer you use the real number, which is 365. That's just me. Multiply that all together and get an answer for interest, which is money, please, money.
$600.
600?
69.86. 69.86.
600.
$69.
$69.86.
Oh, $69.
$69.86.
And 86 cents.
Now we got a button for
Now, does that answer the question?
No.
No. How much does Paul owe on the date of maturity? $1,069.86. This will answer the question. And that's it. That's how you use the day chart. Now, one of the problems with the day chart is this. If your start date was November 3rd, and you have to add on 150 days, how do we get to the next day? Well, what's November 3rd on the day chart? 307? So if we take 307 and we add on 150 days, we have a problem.
We don't have 457.
It goes over 365.
So do you stop at 365 and start at the top?
Yes and no. You could like count, but that would take too long, so there has to be a better way. So the way to do it is, well, I know I'm going to go over a year. So what I'm going to do is find out how many days are to the end of the year. So you take your whole year, you take away the 307, how many days are left in the year?
58.
What is it?
58.
58. So from November, 58?
Yes, we
Wow. From November 3rd, there are 58 days left in the year. Okay. So from here, we already used up 58 days of 150, right?
Yeah.
So we do 150 minus 58. There's other ways of doing this. I mean, this is just one possible way of getting around the calendar. So subtract those and you're down to?
92.
So you have to go to the 92nd day of the year, which is?
April 2nd.
April 2nd. So this loan will get done
365.
on April 2nd. So that's one of the problems. If you have to go past a year, you have to kind of figure out how many days are left in the year and then figure out what's left after that. It's a little weird.
Is it like a prorate thing?
No, this isn't prorate. I'm just trying to get from one date to the next date. And the problem is November is really at the end of the year, so I have to kind of go into the next year. So the first thing you have to figure out is how many days do I have left, and then after that you can figure out how many days into the year you have to go.
Mr. K,
Yep.
why don't you just add it just like you did at the top,
And is
307?
it
You can. Like I said, you can, and then take away 365. There's other ways of doing it, but I wanted to show why you have to.
You want to go the long way.
No, it makes sense. Get to the end of the year and how many days after that. This way, people get confused because then they're like, "What are you subtracting?" Yeah. I've done this enough times. I know weird questions that come up. Like I said, there's multiple ways of doing it. Okay, so that's enough for the day one. Now, discount rate. Discount. We talked a little bit about this when we were talking about the check and go places, why they got shut down last time. Because they charge you an interest rate and they want $10 out of your paycheck. So they keep $10 out of your $300 paycheck and they give you $290. The problem with that is they're not giving you a chance to pay your interest. They're taking the interest before you even get the money, which is totally opposite of regular loans. Regular loans, you take the money out, like this $1,000, and at the end you pay interest. A discount, you pay the interest first. And right away, that makes things a little strange. Because you're paying the interest first, you're not getting the full use of your money for the entire period of the loan. You're getting a short loan. Alright, so let's say, for example, Mary used check and go. I think that's what it used to be called, check and go. I don't remember though. Use check and go to borrow $300. To get the money, they want $10 fee. Now they call it a fee, but the fee actually turns into interest. So that's where they get you. What is true APR? That's what we're interested in. They're loaning us this money. What kind of interest rate are they offering Mary here? So this is actually a two-step process. First step is to figure out. Did I screw this up? Hold on. No, I didn't. The first step is to figure out. No, I could probably go right for it since I gave you the fee. I'll come up with another one that starts with a percent. Since they gave you the fee, I can set this right up with I equals PRT. If I gave you a percent to begin with, it's a two-step process, but because I gave you the fee, we're okay. Do I know how much interest they charge me?
No,
$10. They charge $10. Look what? They charge you. Anytime a bank charges you money, it's an interest. It can be lumped into interest. Here's the fun part. What's the principal? You pay $10 up front. They only gave you $290. We're trying to find the interest rate. Now, the time I didn't really elaborate, but most people get paid weekly. So let's say a week. She borrowed this money on Monday and has to pay it back on Friday. We'll consider that a week. Or if you want 5 days. 5 days? 5 days.
But, well, hold on. How can she borrow the money on Monday and they took $10? They already took the $10 before they gave it to her.
Right.
So how's she going to be paying something back?
No. The way the check and go places worked is I'm getting paid. You go in with a pay stub and say I have a job and this is my normal pay. They would give you that money for the week.
Okay.
But then they would fee you part of it. So you didn't get your full paycheck, plus you got your paycheck early. So when your paycheck comes in, it's theirs. You signed your paycheck over to them getting the money from them.
Okay.
So when you get your money, you get $290
Right.
because you already paid the $10 up front.
Okay.
So they really, I mean, even if they gave you $300, you're still paying them $10. That brings you down to $290.
Okay.
And let's say it was 5 days. 5 days. You got it on Monday, and you're paying it back on Friday. 5 days. So that would be times 5 over 365.
Mr. Kwan, do you not see me over here?
I'm sorry.
I've been doing like this. You don't see me.
Well, it's because my eyes are over here. I'm sorry.
The way you wrote it before you put weekly in there,
Yeah.
if you write it just like that, how are we supposed to set it up if you don't put weekly?
I have to give you a time frame.
So when you do the test, you're going to give us...
Oh, yeah. I'm very specific about that. You can have weekly paychecks, bi-weekly, monthly is usually the most common for state employees. Imagine doing a monthly one. Oof. No, thank you. All right. So how do I solve for R? Gotta do something. Multiply 290 times 5 divided by 365. Get an answer.
39.
Precise, exact.
39.72.
Give me 4 decimal places.
39.72. 73.
Give me 4 decimal places.
3.9726.
7926 times R. You want these 4 decimal places for accuracy. Because we're rounding it what?
I got
3.9.
I got 3.9.
Oh, dear Lord. Calculator people. 10 equals
3.9.
3.9.
726.
726.
Which R now?
Times R. Okay. How do I solve for R?
Divide.
Divide both sides by 3.9726. And you get R is equal to a decimal value of 0. God, I hope it's 0. Nope, it's not 0.
It's 2.517.
2.5. Give me 2 more decimal places.
517.
517. Okay, ready?
Yeah.
This is R equals 2.517. What do I have to do to that number? I gotta change it into a percent. Multiply by 100. That gives you 251.7% APR. This is why those check and go places went illegal. Because they were charging outrageous amounts of interest for a very short loan period.
Are we going to be going by what the bank says when we do our test, like the 360, or are we doing 365?
My test, 365. The book probably does 360. So if you're off by a few pennies, that's probably why.
And will your weeks be 5 days or 7 days?
Oh,
Yeah,
well,
that's what I was looking at earlier.
it's generally on a weekly, but you took it on Monday, you paid it back on Friday, 5 days. A week is generally 7 days. But then you have to talk about banks, and banks aren't open on Sunday, so it gets really weird.
I was just wondering, why is it called a discount? To me, I think of discount
I
as
know.
saving.
Discount in the sense of they take your loan and they're discounting it. It's getting smaller.
Also, it's a discount for them.
Yes. It's actually a higher profit margin. It's a higher profit margin. Because If they charged it $10 at the end of the loan, things change. It would be 10 times 300, or equals 300, which changes the whole proper. You know, you're going to have a smaller interest rate.
Okay.
You're going to, by charging you early, the interest rate goes up a little bit. So they make even more profit on top of that. Guess what they love? Profit. Guess what they don't care about? You. Alright, so that's discount note. Next up, 8.3. You're going to hate this, and I know it. Of course, I don't care. So the next one up is how banks kind of work in certain situations. Interest. Banks do simple interest loans. They generally do it to businesses that borrow the money for a short period of time and pay them back afterwards. Kind of like the construction business. When they start working on, like my garage when it got destroyed during the hurricane, when they started working on that, I didn't give them any money. And they built the entire garage, so how could they afford to pay their workers without my money? Well, they go to the bank and they say, I want a short-term loan. They'll give them a short-term loan on simple interest. They pay their workers, and then I pay them, and it's usually done within a month. If it's over a month's period, then it jumps into what's called compound interest. So if you have a savings account, and you deposit money into a savings account, it's earning compound interest and not simple interest. So this is where the formula starts separating into two different ideas. Compound interest is gaining interest on top of interest. So if you put $100 away today for 10% interest per month, which is outrageous, you'd have $100 this month. Next month you would earn $10 in interest because it's 10% interest. So you'd have $110. But then the month after that you would have $121 because you'd get $11 of interest on how much money you had to start with. So compound interest is just basically interest on interest. Where simple interest is only interested in the principal, compound interest is interested in your balance at the end of the month. Oh, I should have went over one more thing on simple interest before I jump into this. Yeah, I'm going to have to. Because it explains something about compound interest. Or I could do it later. No, I'll do it later when we're talking about loans. Okay, so compound interest is interest on top of interest. So if we use this formula, by the way, this is simple interest. It has nothing to do with compound interest yet. It has a little mixture going on here. We're still going to gain interest per period simply. But then we're going to add it into our principal to create a new principal. So let's say we have a few things. We're going to put $100 away. Save $100 in beginning of month. Let's say March. So at the beginning of March or at the very, very end of February, 29th would be perfect this year, we put $100 into a savings account. It earns 100% APR, and our bank is computing interest every month. It's wordy. I wonder if there's an easier way to say that. Oh yeah, compounded monthly. But that's what it means. It's computing interest every month. Okay. So let's say we go at the end of the first month, which would be the end of March. The very, very end of March. I want to compute how much money is in my bank account. All right. So we're going to go, well, the final amount in my bank account is going to equal my $100 I put away at the beginning. I really could have left that as P, but people like seeing some numbers. 1 plus Now, what's the interest rate? Well, the interest rate is 100%. So what do I put in here? If it was 15%, I would write 0.15. What do? You divide by 100. So if I divide by 100, I get R. The 100 goes away. The R is left over. So you get R. Now I'm computing this in 1 month. My time frame here is 1 month. So what's T become? No, 1 month. 1 over 12. So this becomes 1/12. If I was talking about days, I would use 360 or 365. Okay, is there a way of simplifying R times a 12? I'm not going to be able to use this one. It's R over 12. R times 1 over 12 is the same thing as R over 12. Okay. So I can rewrite that as not P, 100 times 1 plus R over 12. This number right here, this is my new balance, new principal. My principal is not $100 anymore. It's $100 plus a little bit of interest, So when I come down to month 2, the end of April, I'm going to go A equals, now my P is not 100 anymore. My P is what's in the black box. So P is 100, 1 plus R over 12, and then I still have this 1 plus RT thing to put in here. So it's going to be parentheses, 1 plus R times 1 over 12. I'm writing them differently so you can see that one is from the previous month, the other one is the new stuff. So this is P, and this is 1 plus RT. But 1 plus R over 12 is the same thing as 1 plus R times 1/12. So what's 1 plus R over 12 times 1 plus R over 12? Good Lord. What's X times X?
2 plus
2x.
2x.
No, that's X plus
X
X.
squared.
X squared. Good Lord. So this becomes A equals 100, 1 plus R over 12 squared. Because X times X is equal to X squared. X plus X is equal to 2X. Okay. Now we get down to month 3. Well, again, this is our new principal. Another one. And it keeps changing month to month to month. So when I get down to month 3, we have A equals P. That's P. And then I have to multiply it by the interest part of it, which is the 1 plus RT. But when I multiply by 1 plus RT, I get this. For a grand total of,
100.
that whole thing just turns into Q. So it's 100 times 1 plus R over 12 raised to the 3rd power. Yay! You starting to see a pattern?
Yeah.
Okay, so if I go to month 24,
It's just that with 24 in it.
it's just that with 24 on there. So it's A equals 100 times 1 plus R over 12 raised to the 24th. Now, there's a little problem with this pattern, and the problem is this. I'm going to write it over again here. A equals 100, 1 plus R over 12 raised to the 24. 24 months. We don't like talking about months. Interest rates are usually based on a year. So how many years are 24 months? 2 years. So the first thing I want to do is I want to indicate that we're really talking about 2 years. So I'm going to write it this way. Where the 2 is years. Notice what happens though. This number that I put here in the denominator is the same as this number up here. Where did I get that 12? Because over here it says I gain interest every month. What if I change that word into every day? Well, that would change the 12 into 365. And what happens is this would become 365. To get the right exponent, I'd have to have 2 times 365 to make it 2 years. So these two numbers in green circles would always be exactly the same, which is cool. So the formula comes out to be this. Compound interest the formula looks like this. A equals, the 100 is actually your principal that you started with, 1 plus r over n raised to the nt. Everything is exactly the same as simple interest except for one letter. What letter is that? N. It's the only one different. N is equal to the number of computations per year. The number of computations of interest per year. When you have a savings account, how many statements do you get per year? 12. You get 1 for every month, and every month they give you a little bit of interest, even though right now it's like 1%. Ridiculous. So, let me ask you a few little questions. Compounded, and then I'm going to say yearly, and you're going to tell me what n is equal to. If I compound my interest yearly, how many times am I paying interest? 12 times a year? One time, kind of like your birthday. Happens only once a year. The other one that goes with this is annually. Annually and yearly. So if you're only getting an annual payment, n is going to equal 1. What about semi-annually?
Twice.
You're going to pay it out 2 times a year, every 6 months. 2 times a year. What about, the next one up is quarterly. I like when people say 3, because they're thinking it's 3 months. But it's how many times per year. In quarters, how many in a dollar? 4, so n would equal 4. Monthly is the easy one. That would be 12. And then weekly is 52. And then daily, 365. So if it says compounded yearly or annually, you'd say n is equal to 1. If it says compounded monthly, you'd say n is equal to 52. If it says compounded daily, n is equal to 365. So far, so good? Let's work one. You have to get used to a few buttons on your calculator, though you should have already done that in Chapter 4. The other buttons you might want to get interested in are these parentheses. They're right above number 7, I think. 8 and 9, someplace up there. Get used to these parentheses, because if you try to do this piecemeal, generally what happens is you get the wrong answer. If you type the whole thing in at once, you're usually pretty safe, because the calculator is doing all the work for you. So, here's a little example of compounding. I got arthritis. Get old. Neil put $500 into a savings plan that earns 7% interest compounded quarterly. How much will account be worth after 5 years? I'm going to break this up into a couple. Alright, so Neil put $500 into a little savings account. The thing with this formula is you make one deposit. one transaction and you never touch it again. Does that make sense? I'm not putting $500 away every month. I'm just putting $500 away and then I'm ignoring the account for 5 years. So to do 5 years, I'm going to set it up with A equals P parentheses 1 plus R over N raised to the NT. Why do I not use I equals PRT? Why not simple interest?
Let's go.
Because there's a key word in here called compounded. I didn't write it all the way out, but trust me, your word problems. If it says compounded interest, it definitely is not simple interest. It definitely is not I equals PRT. So this would be the first formula you think of. Now after this, there's 2 more we have to worry about, and they both say compounded, but there's other key words to tell you which one to use. But the first one is to get it away from simple interest. Now, what if this, instead of 5 years, what if I said 3 months? Do I have to use the compound formula? No. If it's 3 months, I can use simple interest because it's within the period of the compounding. But once it goes over that 3 months, I have to use this formula. So below 3 months, I can use simple interest. Above 3 months, I have to use this formula. If you're confused, use this formula right away. Just be done with it. All right, do I know A? No, leave it alone. Do I know P? That's $500. 1 plus, do I know the interest rate? How do I write it? 0.07. My favorite mistake is when people put 0.70. Imagine what that does to your answer. 70% interest rate. Woohoo! I'd go for that bank every day. Yeah, sure.
It's kind of like having a money market account.
Similar. Money market accounts are compound interest, yeah. But they're also based on market conditions, so the interest rate's always changing.
And that that you underlined 3 times is compounded.
Compounded, yeah. I just didn't write it all the way out.
Compounded or compounded?
Compound, either one.
I have a question.
Yeah.
Okay, like on your calculator.
I haven't even gotten to the calculator yet.
No, but I'm saying.
Hold up, let me get this down first. 0.07 divided by.
5?
4.
What does N represent? The number of computations per year.
4.
4. Why? Because it says quarterly, which is right here. Oh, shoot, I'm writing on something I shouldn't be. Back up. All right, so this is 4 raised to the, then you copy it over again. 4 times 5. T is years, how long you're going to keep the money in the account. Now, before you start typing things into a calculator, do this calculation first. This is the one that screws people up. If you just type it in the calculator the way it looks, generally people make a mistake with that 4 times 5 bit. So just change it into 20. When you type it in your calculator, it's going to look exactly like this. That's how you type it in your calculator. Now you can ask your question.
Okay. When you doing like the percent right here.
Uh-huh.
Okay. If we was to like use our calculator, say 7-second percent, would that be wrong?
No. Do I want you to do it that way?
No.
No, because it's not showing me you know what the heck you're doing. It's showing me the calculator knows what it's doing. Don't use it. Because I'm going to be looking at what you write down. If you write 7% in there, I'm going to take off points. I want 0.07. What do you get?
707.
707. 0.39. $707.39. So how much interest did he earn over a 5-year period?
Subtract 500.
Yeah, it would be $207.39. That's not bad if you think about it. You just let the money sit there and he earned $200. All right. Now my second part of this is do simple interest on this. What if this was a simple interest loan? Just curious. Would he earn $200? Let's find out. A equals P parentheses 1 plus RT. That's a simple interest formula. Do I know A? You could use I equals PRT, but I want the final amount so I can compare it to this one. So A equals, what was it, 500. If it was a simple interest, it would just be 0.07 times 5. Type that in your calculator and see how much you get. Type it in.
675, I think.
$675?
Yeah.
$675? Anybody concur?
Yes.
Or are you just trusting the first calculation? Notice the difference. This one only went up $175. This one over the 5-year period went up $207. If we take this to 10 years, what happens is those numbers get further and further apart compared to simple interest and compound interest. There's a reason for this. Do you remember your nice algebra? Yeah. Remember algebra? Do you remember graphing?
Yes.
Really? Let's find out. If we were thinking about graphing this, it basically is A equals Rx plus P, where R is your interest rate. Basically, kind of like this. Not exactly, but basically. How do you graph something that has Rx plus P? What's R represent? No.
Well, you know, you skipped that time.
Oh, I'm sorry. Here, let me write it this way. Y equals mx plus b. What's the m represent? Slope. The number in front of x is your slope. The number not the x is your y-intercept. So this graph is starting at p dollars, and it has a slope. Well, I probably drew it too steep, but it has a slope that brings your money up over a period of time. So you get a little bit, but it's always the same little bit. Every year you make the exact same amount of interest. Compound interest, on the other hand, starts at the same value, follows this graph for a while, but after a while it starts taking off. It has a curve to it. It's called exponential growth. So as time goes by, the amount of money in the account is going up exponentially. It's almost going straight up after you go far enough. For instance, here's a good example. I found this in another book. GW borrowed, I think it was $150,000 in gold. Who's GW? George Washington. During the Revolutionary War, George Washington was running out of money. The government was actually running out of money during the war. So he borrowed $150,000 from a very rich businessman. $150,000 in gold. This was in 1777, I think it was.
Does that matter?
Way back in 1777.
Does the year matter?
Huh?
Does the year matter?
Yeah.
Should we be writing this down? Like,
Yeah.
Yeah.
Yeah. The government never paid this man back. No money from the U.S. government has ever gone to this man's family until recently. In 2005,
They don't even know who it was that they got.
yeah, you can go back genealogy and find out who your parents and grandparents are and all that fun stuff. Well, a family went back and found out that they were this businessman's relatives. They sued the government for this money with compound interest.
It's a true story.
This is a true story. It's probably still in court, or they came up to a settlement. But let me show you what happens. If they just charge the government basic inflation of 3% per year,
Wow.
that's compounded annually, right? This becomes A equals $150,000, parentheses, 1 plus 0.03 over 1, because it's annually, right? Raised to the 1 times, well, how many years is that? 205 minus 1777. 228 years. Now, this is why simple interest would make the government happier. Type that in your calculator and see what number you get out of it. Just tell me the numbers. Shh, hold on, just one digit at a time. 1, 2,
6,
6,
7,
7,
5,
5,
8,
8,
9,
9,
0,
0,
8,
8,
0.8.
0.80. Boom,
They
Boom.
good for the rest of their
That's
lives.
$126 million that the government owes this family because they did not pay his grandfather back, or great-great-great-great-grandfather back. Now, obviously, the government is not going to give them $126 million. So they probably settled, but just think of what the settlement would be. Even if they got 10% of this, that would be $12 million. 10% of this is $12 million. The family would be paid $12 million. Pay off what you owe, otherwise you are going to get hit hard in the end. This is the power of compound interest. Now, if this was simple interest, do this one. A equals 150,000 times 1 plus 0.03 times, what is it, 228? The simple interest on this is nothing. Well, comparative to $126 million.
Well, compound interest is interest
On top of interest, on top of interest, on top
Over and
of
over.
That's why it gets so big quickly. What's this one turn out to be?
1176.
1176
000.
000. $1,176,000. That's nothing compared to the compound interest.
That's crazy.
Isn't that crazy? So,
Compound interest.
this also goes towards car loans, mortgages, and
Stay
so
away
forth.
from that.
Like car loans, if you get one for 4 years, that's standard. You get one for 6 years, guess what you're paying?
Compound.
A lot of interest.
I wonder how they found out that they owed.
Yeah, that's the thing.
That's what I was
They probably went through records and said, oh, look, here's $150,000 coming in, and they never showed $150,000 going back out. And they do keep records of this stuff. Either that or the old man, wrote down his anger that the government never paid him back,
They found in a time capsule.
and then they found out they can sue. We have a little bit of time. So let's do one more type of problem. Oh, how horrible. Oh, I'm running out of names.
Neil.
Susan found grandma's bank book with a balance of $25,328.12. Grandma did not keep her money under her mattress. I knew people that did that. It's very scary.
In the house burner.
Yeah, and then their house burns down. I would like to claim that out of my insurance. Okay, good luck. So, Gran started this account 35 years ago at 3.5% compounded monthly. She made no deposits or withdrawals. When I was a kid, wasn't that long ago, but when you had a savings account, they gave you a little book. And when you deposited money, they would take the book and print on it how much your account went up or down. It would always show the ending balance. And when you filled up that book, you got a new one. So let's just say that Grandma just has a book that shows the final amount. It doesn't show the beginning amount. It doesn't show how much she started with. So how much money did she initially deposit? Can I go backwards and find out from the total amount at the end to find out how much she started with in the beginning?
Yes.
Well, I hope so. I have a lot of information. I have this number, which tells me A. I have this number, T. I have this number, R. And I have this number, N. I have everything except for P. So when I write my formula down, A equals P parentheses 1 plus R over N raised to the NT. Why do I keep writing the formulas down? One, you can memorize them if you wish. Number two, you need to replace everything up here with every piece of information that you can and leave alone just one. You have to leave alone just one. Do I know A? That's $25,328.12. What's the most common mistake on my test? They take this number and put it in for P. Big mistake. It's the end number, not the beginning number. I don't know P. 1 plus 0.035 divided by 12 because it's compounded monthly, raised to the 12 times 35 years. The first calculation you should do is the 12 times 35. So what's 12 times 35? 420. You know, cross that off, right? 420. Now, I need to solve for P. So what should I do? Take everything to the right of P and type it in your calculator. This is just some ugly number sitting next to P. Yes, you have to put the parentheses because there's a power on the outside locking them in. So parentheses, 1 plus 0.035 divided by 12 raised to the 420th power.
3.39.
Give me 4 decimal places.
3.3981.
3.3981. This is times P, and this is equal to our $25,328.12. How do you solve for P? Divide both sides by 3.3981. I love when people divide both sides by 25,000 because they're always thinking, yeah, go this way. Make sure you divide by the number that is next to the P. And we get P, which is an ugly answer, but it's okay.
7,453.6. How many decimals are wrong?
Oh, it's money.
Oh, well, 61 cents.
61 cents. Yeah, you have to recognize when you've got money, you want 2 decimal places. When you have percents, you want 3 decimal places. So she started with about $7,500. Now, there's a huge assumption on this, and this isn't true in the real world. Her interest rate is 3.5%. How many bank accounts can lock in an interest rate of 3.5% for the life of the savings account? None. I mean, mine has gone from 5 down to 1. 1%. Woo-hoo. What's the point of saving money? Okay. Now, there is one more formula that you have to worry about for homework, but not for the test. There's a cool little thing that happens. There's a cool little thing that happens if we graph this. Instead of changing time, what I'm going to change is just n. So I'm going to fix time, fix how much money I'm putting away, fix the interest rate, fix everything. All I want to change is n. What happens is, you'll start off here at P, and your graph will go up like normal, a little bit, but then it turns and does this. And it comes up to a maximum value, which is kind of cool. Max. It comes up to some maximum value. And you can test this out. You can take a simple problem like A equals 1,000, 1 plus R, or 0.05 over n raised to the n times 10 years. And all you have to do is change n from 1 to 2 to 12 to 365 to 10,000 to 100,000. And what you find is your answer doesn't change that much after a while. And eventually it locks down onto one single answer. Once it does that, what we've done is we've made n so large that you're counting interest every second of the day. I earned interest for 1 second, and the next second. And then you break it down even smaller than that. And what happens is the formula transforms from this into this, which is really, really cool. E, it's on your calculators. You'll find it under LOG or above LOG. So it's second LOG. I'm sorry, second LN. Second LN. So to type in something like A equals $150, E raised to the 0.05, 15 years. To type this into your calculator, you're going to type 150. You're going to hit second ln. What that does is it puts E caret parentheses on your screen. And then you put in 0.05 times 15. And you hit enter.
That sounds good.
317.55.
And what you said, hit Mr. Clark and get the E up there, 'cause I'm trying
Second
to.
ln. Shift
Mr. K.
ln.
This is money, right?
And then you'll have to hit caret parentheses. Yours doesn't do the right. Yeah, this is money. So after 15 years of continuous compounding, this is called continuous, it's happening all the time, you would get $317.55. It's the maximum amount of money you'll get for any compounding possible. Which is kind of cool if you think about it. Now, do you think any bank gives you continuous compounding? Heck no. So what's the use of this formula?
None.
Population growth. Bacteria, it's always growing. So you can't say it only grows every year, because then if it grows every year, you'd start off with a little bit, and then at the end of the year it goes boom, and you get this a huge amount of it. It's always growing, so you have to use this formula. A equals PERT. Continuous, I'm going to call it growth. Because it actually doesn't, I don't think of any bank using a continuous compounding formula.